standards and why do we need to use them? They're really important in the risk assessment and management of risks within the workplace. Excess levels of airborne contaminants in the workplace may lead to toxic effects such as respiratory diseases of asthma or maybe even silicosis. Can lead to cardiovascular diseases, simple narcosis, or even occupational cancers such as bladder cancer or leukemia. By understanding a worker's level of exposure, then we can compare this information to determine the significance of exposure and the level of risk to that particular worker. We can also assess if health monitoring is required in order to prevent illness developing with the aim to reverse any health effects. There's more information in the regulations from Safe Work Australia about which substances require health monitoring and when it does need to be carried out. For compliance purposes with the WHS or OH&S legislation, employees must not let their workers be exposed above the exposure standards. In fact, exposures need to be kept as low as reasonably practicable. And finally, workers may have a concern about a particular exposure or a particular chemical in their workplace, and therefore measurement may be required to ensure they are not being exposed or put in place various control strategies to minimise that exposure. Safe Work Australia also provides additional information about various chemical hazards which is important when working with the exposure standards. And these are categorised according to the GHS, the Globally Harmonised System for Chemicals. So where chemicals are noted as being carcinogenic, cause skin irritation or even could be absorbed by the skin, or they may be a sensitiser chemical which can cause diseases such as occupational asthma. It's really important that OH&S personnel and occupational hygienists consider the implication of exposure to these chemical hazards and to work to reduce exposures and control them as much as possible for any person who has to work or handle these particular chemicals. It's important to remember that the exposure standards have certain limitations. They're not fine lines between safe or unsafe in terms of working environments, as a small number of workers may be affected at levels below the exposure standards. Therefore, airborne exposures must always be kept as low as reasonably practicable. The standards are not the same as road speed limits where you can drive right up to the limit or perhaps even fudge a little bit over. So to protect worker health, exposures should always be kept to at least half of the exposure standard. And this is sometimes known as the action level. And this helps to drive good practice and also can be used to implement various control strategies. The exposure standards are designed for use in the occupational environment only and are not applicable for use in the wider community, as there are elderly and children present in that environment. Although some chemicals have a risk phrase for the skin, it's not taken into account when setting the airborne exposure standards. In this case, biological monitoring may be more appropriate to assess the total body burden from exposure via inhalation and skin absorption. When evaluating exposure, we need to know what, why, how and when. So prior to conducting any sampling, an exposure assessment program needs to be developed by doing some research into the specific chemical to measure and to ensure the valid test method and for a capture and analysis is used to measure that worker's airborne concentration. Also, we can use the results of personal sampling to compare against the exposure standards. Now here we can see this air sampling equipment being placed onto this worker who's going to wear it for their whole 8-hour shift. And this is the type of sampling that an occupational hygienist will be able to do for you. So here is an example of what a worker's exposure looks like over a typical 8-hour day. The airborne concentration of this chemical substance usually varies throughout their shift, due to various factors such as intermittent or various work tasks and the quantity of chemical used throughout the day. This graph shows the variability of those airborne exposures that a worker can experience over the whole 8-hour day for a specific chemical. In this instance, the worker's exposure is averaged over the whole day is the time-weighted average of 27 parts per million. But the highest peak can be seen, which is the exposure measured over a specific task, and that was measured at 50 parts per million. Now, these measured values can then be compared against the relevant exposure standard for that specific chemical. In this case, the TWA exposure standard is in fact 30 parts per million. Remember, the exposure standards are not hard and fast rules of satisfactory or unsatisfactory. So because the result here of 27 is very close to 30 parts per million, the exposure is actually too high, and various controls would need to be used in order to reduce that exposure to at least half of the exposure standard value. However, if this worker is working a shift that's longer than 8 hours, then the exposure standard may need to be adjusted because there is less time for recovery and for the substance to be eliminated from the body before the worker fronts up to work for another daily dose. So the occupational hygienist will calculate an adjustment which is suitable for that specific substance using a standard method. In many cases, the new adjusted value will be less than the TWA exposure standard, and therefore controls will need to be implemented to keep exposures down and to reduce any health effects. To determine the exposure, we must